Hello, everyone. Good morning, good afternoon. Dear authors and invited guests, welcome to Technical Session 10F. Myself, Deepika Jain, and this session will be moderated by me. On behalf of Global Knowledge Research Foundation and GR Scholastic LLP, I welcome you all to the 9th International Conference on Smart Trends in Computing and Communications, SMARTCOM 2025, Pune, India. The ninth edition of this conference was held in Pune and is organized in a hybrid mode. Uh, the virtual event is being held to Zoom platform that is on 30th and 31st January. I hope you will enjoy the knowledgeable sessions throughout the day. Every presenter would be getting 8 minutes for their presentation and 2 minutes for question and answers. On 7 minutes, I'll be raising a gentle reminder. And in case if you have any questions, you can write to me in the chat box. I also request all the participants to be with us till the closing remarks. And if you have any query, you still can write to me, yeah? And just before we start the session, I would like you to introduce to our session chair, Dr. Satish S. Banet. I welcome you, sir. He is currently working as Associate Professor, Department of CSC Sandeep University, Nasik. He has published 34 research papers in various journals and 17 papers in various national and international conferences. He is a reviewer of reputed national and international journals. His areas of interest includes data mining, artificial intelligence, machine learning, big data, IoT, and software engineering. Thank you, sir. I welcome you, sir. Okay, so we'll begin with our first presentation. Neha Singh, you would be presenting a paper on a comprehensive literature review of the function of electronic word of mouth in online social networks.
Ye-
Can you hear me, Sneha?
Yes, ma'am. Very good afternoon.
Good
Am I
afternoon.
audible to you all?
Yes, you're audible. Can you start sharing your screen, please?
Yes, ma'am. Please wait a second. Are you able to see
Yes,
my
yes,
screen, ma'am?
yes, yes.
Okay. So my paper ID is 766 and my topic name is a comprehensive literature review on the function of electronic word of mouth in social networks. So let me just start. Okay, if I introduce my topic to you, then electronic word of mouth is nothing but the online reviews that we read via the help of internet. Actually, it if I am planning to buy something and I am not sure about the quality of the product, then I would definitely would want to know the online reviews regarding the product, and it is. Prior to my purchasing behavior, it's when I am planning or willing to buy something, then I would definitely read online reviews regarding the same. Then online reviews are electronic word of mouth are nothing but the online reviews, and innovations in information technology are exploding all around and give purchaser special chances to migrate their uh, queries regarding the products and services. And one second, ma'am. Ma'am, are you able to see my screen?
Yes, I am able to see your screen. We can move the slides also.
Yes, ma'am. Act, Consequently, after the spread of mobile technology, the electronic word of mouth services has been changed into the mobile context. Potential consumers share their real time buying experiences with the others anytime and anywhere using their cell phones. As I was explaining, that consumers can anytime they can use other consumers' online reviews regarding the product if they are suffering any sort of risk, or they are having any doubt. They can easily read reviews of other consumers. And considering the great explosion of online social platforms, example Facebook, Instagram, YouTube, Twitter, etc., in the past several years, EWM has a major impact on particular. Actually, ma'am, I'm not able to see my screen. I don't know why.
I can see your screen, but I cannot see your slides moving. It's still on the introduction page.
Yes, ma'am. Just a second.
You can stop and reshare again.
Okay, okay, ma'am.
Akash, are you here?
Hello, ma'am. Yes, ma'am. I can hear, ma'am.
Are you ready with your presentation?
Yes, ma'am. Can I do it, ma'am?
Yes, please.
Wait one second.
You are
Let me share
presenting a
my screen.
paper on blockchain technology for strengthening content protection in e-voting,
Yes, ma'am.
right?
Wait. Just one
Yeah.
second. Let me see.
Share your screen, please.
My
Meantime,
screen
Sneha, you
visible,
can
ma'am.
just fix your issue and come back next. After Akash, you can present. Till then, please fix your issue.
Is my screen visible, ma'am?
Yes, your screen is visible.
First of all, good afternoon, ma'am. Myself, Akash. I'm going to present a paper based on the blockchain technology for strengthening content protection in e-voting. Okay, let me go to the introduction part. First of all, voting, which is an important factor in democracy, but it still has its own issues, including fraud, complexity, and a lack of transparency. These issues are arise from the traditional voting systems, which is based on the central mechanism, which makes them more vulnerable and easy to hack or delete the data. So now there is a need for an electronic voting machine, which provides trustworthiness and integrity and accessibility. Let me show you some of the limitations in existing voting system. The most important things are lack of transparency because the people cannot able to see how the votes are managed clearly, which makes them it is people cannot trust it blindly. And the second is security vulnerability. If in case the votes, in case the EVM machines are hacked or it is stolen, all the votes are at risk. There is no way to retrieve the already post votes. And the third is the auditability. Even though there are VVPATs and other things, we cannot surely verify that our votes are correctly registered. It is based on the system only. And the common issues like scalability, fraud risk, and user accessibility challenge. Some of them are still in India based in India. Some of them still don't know how to cast the vote correctly. Next, we move on to the objective. What is our main objective is to make a voting machine which provides trust to users and give them an proper way to use them. And the votes are secured in a proper way. For that, we use as a blockchain. Blockchain stores the votes in a hash block, which makes them hard to hack or any stolen information. And multi-factor authentication using OTP like system, which makes them more secure. Third is real-time update. We provide pie charts on gender and age demographics. We can we can get useful insights from the data. So the next slide is methodology flowchart. We can see there are three blocks. First thing is organizer and blockchain and voters. Organizer is the person who has the ability to control the election. So he can connect his MetaMask and add candidates and time for the election, and he can start the election. Once the election started, the voter's part came. The voter needs to connect the MetaMask as well and give his password. And he need to verify his email OTP first, which is make them more secure. And he need to fill his details and the candidate. Once he submitted, he can cast his vote. Once the vote is casted, it stores in blockchain. The voter has to confirm the vote also in the MetaMask ID using the transaction fee in Ethereum. Once the votes are has stored in the blockchain, they just safely stored in the contract which we already deployed. Once the election ends, the organizer has to retrieve the result and show it to the other person. The results stored in the blockchain are retrieved without any problem. Next, we go see about the implementation overview. Authentication with MetaMask. MetaMask is one of the most secure wallet for storing the blockchain currency. It uses an two-side encryption mechanism of private key and public key. And the second is role-based access control. We can see in the previous slide there are two blocks, voters and organizers. The voter has its own set of things and organizer has its own set of things. It do not conflict with each other. The website and the interface provides a clear and smooth control flow using this role-based access control. And the third is multi-factor authentication, which I already tell the email OTP verification. Even though in India there are voting IDs like physical authentication system, the hybrid mode authentication makes it more secure. Next is real-time vote tracking. Once the voter cast his vote, he can able to see that his vote is applied to or not. There is a total vote where he can see that his vote is casted. It makes them it gives them a trust that his vote is casted. And the demographic and voting pattern. The pie chart and the age gender chart gives them the insights. Next, we see the results. This is the organizer page, the first page, where the organizer need to provide the names of the candidates and the starting time and the number of time needed for the election, and he can start the election. Once the organizer starts the election, he need to confirm the contract. Only the organizer ID can confirm the vote contract. Once he confirm the contract, all the voters have the ability to view this page, the cast vote page. Here, the candidate has to select his categories and the candidate and need to first validate the OTP. Once he can validate the OTP, he can able to send the vote. This interface provides an easy verification system. And the third is once the election ends, he can see the total votes. Whenever the voter casts the vote, he can see the total vote is increased or decreased. Once the election ends, the organizer can show the result that provides the candidate name and ID and the number of votes to them. And the age and the gender chart. We can clearly see the gender and the age demographics, which provide key insights about it. And the final thing is observation. From the EVM we developed, we can able to provide the secure voting recordings and the real-time results and the effective voter verification using multi-factor authentication. And the conclusion and future work, the blockchain is one of the best way to provide secure EVM transaction and the security transparency. Our future work is scalability because in India there are election happen in a huge way. So we need to make a system that has the ability to scale. And the second thing is for security, we will try to do asynchronous encryption, which is a two-key based encryption mechanism, which makes it nearly impossible to crack the encryption codes. And the third is security audits. Just in case if there is any hack or any malicious things that happen in the website, we can easily monitor in this now. And the last is some of the references we have. These are the things about my presentation. Do you have any doubts or anything?
Thank you, Akash. Thank you for the presentation. Sir,
Yeah.
any questions? Satish, sir?
Mr. Akash, am I audible?
Yes, sir. Sorry.
Yeah.
Yes, sir, you're on.
So, Mr. Akash, my question is that only two questions are there. That how can blockchain technology enhance the security, transparency, and integrity in the electronic voting system to protect against fraud and ensure voter privacy?
Sir, in blockchain, the votes are stored in a hashed block, sir, which is whenever the votes are transferred, there are people called miners. They need to verify the contract. And there are millions of miners that working on millions of computer systems that working as miners. So nobody know that the votes are transferred in this hash. In this hash, only the system only knows. And there's no way they can, in case they need to hack the system, that takes them more than 1 day or 1.5 days. But the votes are happening in a very for time. The voting process is for 1 day. The hacking process needs to 1.5 days. So we can clearly see the daily the each vote update. So hacking, even though he needs to hack, it takes them more days to hack the system. We can end the election before he tries to hack itself, so that it increases the security at all.
Okay, last question that what are the challenges and limitations of integrating blockchain into current e-voting system? For I'm talking about the scalability or accessibility or regulatory concerns.
The most important thing was the technical knowledge needed in this using the system, because many people are not even aware that how to use smartphones in India. So we need to educate them in a way how to use it, clearly educate them in a proper way. It can be misused, but there is a way they can able to properly cast the votes. This is one of the important factors. And the Ethereum contract needs Ethereum amount, which is the current for a private Ethereums are costly. Just in case government uses this, government-based Ethereum cashes or Ethereum currencies can use. It will make them less costly.
Okay, thank you, Akash.
Can I end this, sir?
Thank you, Akash.
Thank you, ma'am.
Yeah, thank you.
Is it now visible?
Yes,
Okay. So
start from where you had left.
yes, ma'am.
Yeah.
So I was just explaining what electronic word of mouth is, and we need to just understand its introduction when it comes to IT sector. Then innovations in information technology are exploding all around and give purchasers special chance to migrate their communication from one technology to other. And consequently, after the spread of mobile technology, because the mobile technology is constantly growing, the EWM experience services has been changed into mobile context. Earlier, it was like only word of mouth when people used to talk to each other like verbally, like face to face. But now, with the help of an internet, it has evolved into electronic word of mouth with the help of internet and mobile context. And with the help of that, potential consumers share their real time buying experiences with others anytime and anywhere using their cell phones. And mobile EWM is seen as a powerful marketing tool in the social networking setting, as in various social networking sites like Amazon and social media networks like Facebook, Instagram, etc. And this is because mobile internet plays a special role in the real time discrimination of products and service information. And with the help of this, businesses have acknowledged in the past that mobile applications provide a novel way of communication that has potential to improve sales by recruiting new customers and enhancing the brand loyalty, awareness, and experiences of existing customers. And considering the great explosion of online social platforms, like I've already told you, Facebook, Instagram, YouTube, Twitter, etc., in the past several years, EWM has major impact on practically any aspect of life. And with the growing importance of electronic word of mouth, it is very important, to study this particular concept. And it is very important to study. And in the recent times, there has been a significant increase in the number of research when it comes to EWM communication. And in the current study, we are just trying to find out the in-depth inquiry of the existing body of work with the help of bibliometric analysis. And the purpose of our study was what is the current scenario associated with EWM in context to mobile networks, and to provide a literature review of the relevant search studies, and to provide the thematic clusters along with the emerging topics. So, literature, if we talk about the literature review, we have employed bibliometric analysis, and it helps us in like finding out it is basically a convenient technique to examine the existing knowledge and to attain the prime objective of the study. And bibliometric analysis employs a systematic analysis technique that helps in identifying the most leading researchers, affiliations, most frequently occurring keywords, and other academic work. Basically, bibliometric analysis helps us in finding out the current scenario of the particular research topic. And With the help of inclusion and exclusion criteria, we conducted our bibliometric analysis, and if I talk about inclusion and exclusion criteria, then we only fetched the paper which was we have not included conferences papers, we have not included book chapters, because the articles that are published in journals are considered to be certified knowledge, and we have only used Scopus database, because since Scopus is the largest database with over 20,000 peer reviewed journals from various and different publishers, and the articles which were in English we have only included the articles which were in English language, and our language has been employed in this investigation, and then output file was used to to continue with our research. And as you can see, the paper which was included was from 2011 to 2024, and the sources were total 74, and we have included total 100 number of documents after inclusion and exclusion criteria. And as you can see, this is a growing topic, since annual growth rate of this particular topic is 7.3% percentage, and the total number of authors was 253, and out of which only 8 of them were single authors. And similarly, the total number of references were 66,006, as you can see. And this represents the most relevant authors. As you can see, there are total 10 number of authors, and Fang one is basically the most important author. And as you can see, the next figure is all about authors countries. And actually, ma'am, there's a slide, there's some mistake. Actually, I was not able to share my original slide because of
Hmm.
some error.
Okay, okay.
So as you can see, there are these are the top 10 universities, the universities which are doing the best job in this particular area. And these are the sources, like journals. These are the top 10 journals related to this area, those who are working on this particular topic. So International Journal of Advertising and in Journal of Business Research are at the top with total number of 6 articles. And as you can see, this is the cloud, word cloud, and it represents the most frequent keywords. Actually, that means social networking online it has occurred the maximum number of times in this particular research area. And okay.
Have 2 minutes left.
And this is the findings. These are the top 10 most cited research papers. Actually, these are the most, and I have also done the review of these top 10 articles, as you can see. And I have also done the co-occurrence keyword analysis, and out of which I was able to find out the 5 most important clusters, as you can also on the screen: cluster 1, cluster 2, cluster 3, cluster 4, and cluster 5. And after that, this is the conclusion. As you can see, it represents that
Okay.
it is a ongoing research area, and one should also do research in this particular area in future also. As you can see, this is my conclusion.
Thank you, Sneha.
Thank
Thank you.
you.
Any questions, sir?
Sneha, tell me one thing that how does the evolve influence consumer behavior and brand perception within online social networks?
Yes, sir. So suppose if I'm planning to buy something, and if I have some doubts and queries in my mind before I am planning to buy something, before I'm willing to buy something, then sir, I would definitely go for the online reviews posted by the previous consumers who have already purchased that particular service or a product. Then after reading those online reviews, my perceived risk would be decrease in a decreasing manner, because they have provided us a good number of opportunities, or the pros and cons of the products and services regarding the same product that I'm planning to buy. This way, EWM helps in the consumer behavior when we are planning or willing to buy something after reading the online reviews of the previous customers.
Okay, last question that there are so many differences that how you can handle the differences in your impact across the various online social network, for example, Facebook, Twitter, Instagram, etc.
Yes, sir. Actually, there are many sites who pay people
Yeah.
money to post online reviews, but there are some genuine, authentic sites which we know that they are the authentic reviews of the consumers. So we just need to identify those uh, particular platforms, and the reviews posted there are definitely authentic and genuine, and we don't need to worry about uh, the results, the fake results, and the negative feedbacks.
Okay. Thank you.
Thank you, sir. So should I stop sharing my screen, ma'am?
Yes, please. Yes,
Okay,
please.
thank you.
Thank you. So we have our next presenter with us, uh, Tushar, who would be presenting the paper on cloud network security for wireless networks, a review. Yes, Tushar, you can start sharing your screen, please.
Thank you, ma'am. Good afternoon, everyone, honorable session chair, and all attendees. Is my screen visible?
Yes,
Okay,
you
thank
can
you.
just be a little
So,
bit louder.
sure. Uh, is it audible now? Better now?
Yes, yes, yes.
Okay, thank you. So, good afternoon, everyone. I am here to present the paper on cloud network security for wireless networks. So, my co-authors are Ms. Ishwari Khurd and Dr. R.C. Jaiswal. Now, just to give you an introduction, our objective while writing this paper is to develop a cloud network security protocol using open cloud to prevent security attacks on the network. So we are using a methodology that first we are doing a comparative study of multiple security algorithms, and then we are discussing which algorithm is the best, and discussing more about open cloud based protocol for cloud network security. So in today's world, cloud is becoming an increasingly integral part of our lives, correct? So nobody is researching a lot on how to protect a network which is specifically on the cloud. So what we are doing here is that we are protecting the cloud at a network level. So as you can see, uh, in the first, the packet is arriving at the switch. So wherever the cloud network is situated, at that switch, the packet is arriving. Then this packet arrival is informed to the network operating system. Now it is being checked whether the network operating system will check whether this packet belongs to the existing flow of known packets. Is it expected that this packet is going to arrive? If it is, the answer is yes, then it will correctly forward the packet to its proper destination. Else, it will create a new flow record, so that it will create a new entry that yes, this is a visitor packet, this is an unexpected packet, and it will have to check whether this packet is part of an attack. If this packet is part of an attack, it has to be deeply analyzed. So many of us industry professionals, we are using tools like Wireshark to manually sniff packets, and we are looking at the contents of the packet and everything. This deep packet analysis algorithm will do the same uh, for the network, cloud network. If the packet is a malicious packet, it is informed to the network controller. So obviously we have to have humans involved in controlling the network, and automatically the packet is dropped. If there is no attack detected from this algorithm, then we are forwarding the packet back to the network. So it will reach its intended destination wherever the packet is addressed to. Now, let us look at the algorithm for the entire process for this methodology that we have just discussed. So first, the packet is arriving at the cloud network. So this is where your physical cloud is uh, placed. Then this cloud provider is notifying the cloud network operating system to of the packet arrival. Now, why we are using a cloud network operating system? You might have heard about software-defined networks. So this concept is an advanced version of firewalls that we use in our computers. All our Windows computers, Linux computers are equipped with the default firewall settings. So similarly, those firewalls are only blocking the packets according to their properties. Now, similarly, this is an advanced step in that process. So, if the packet is a part of a known packet flow, then it will be forwarded directly to the destination. But if it is determined by this algorithm that this packet is a part of a new uh, unknown packet flow, or it is unexpected that this network packet will arrive, then it will create an entry, a data store record for this new flow, and then it will analyze it for an attack. Whether this is a part of a MAC flooding attack or a man in the middle attack or so on, whatever. Then, if this step 4 detects an attack, this is notified to the network controller and the packet is automatically dropped. It is then sent to the deep analysis algorithm where it will update its own record of what is a malicious packet and enhance the performance of this algorithm. If no attack is found, then the packet will be forwarded to its intended destination. So after the comparative analysis of all algorithms that we did, we analyzed the support vector machine algorithm, the naive Bayes algorithm, self-organizing map, and open cloud-based security model. So in this, we identified that open cloud based security model is the best. So this open cloud based security model is using latest cloud technologies like Kubernetes, OpenKit, and so on. So in conclusion, so we have drawn 3 conclusions for the same. Now, first is that currently network security for wireless networks is increasingly important as we move towards things like Internet of Things, IoT, and cloud computing. So, cloud computing and Internet of Things are becoming increasingly a part of our lives, and that creates a vulnerability of network security for these cloud networks. So, in addition to this, so these attacks, which used to happen on our local networks and had also breached our virtual private networks, have now been introduced in cloud networks. So similar attacks like eavesdropping, denial of service attacks, and so on. So in this paper, we reviewed and analyzed multiple solutions proposed to stop these attacks, these newfound attacks on all kinds of cloud networks over Wi-Fi, cellular, and so on, even 5G technologies. And the last conclusion that we have drawn is that after the comparative analysis, the model based on open cloud and software-defined networks will work most effectively in curbing these threats to these newfound wireless networks. These models are applicable to cloud networks, so they are compatible with the new technologies like IoT and a network of things and so on. So these are our acknowledgements. And thank you. I'm open to questions now.
Thank you, Tushar. Sir, any questions?
Yeah, Tushar, tell me one thing. So what
Yes,
are
sir.
the key challenges and solutions for ensuring cloud network security in wireless network, particularly in terms of data integrity and confidentiality and protection against cyber attacks?
Yes, sir. So I'll just go to the method flow chart once. Yeah. So now what happens is that in a traditional network, when there is an attack, you are the victim. You are the end user of the network. You are present within the network, so you can see firsthand what is happening. Correct. So because you are a part of that LAN network, ultimately it is going to affect you. But even in cloud networks, indirectly it is affecting you, but you are not seeing it firsthand. It is happening to the cloud server where it is located. And you as a user, suppose you are using a cloud service like Google Drive or Apple iCloud, you are not aware where these servers are located. You are not aware on which network they are. You are only aware of uh, you are perhaps not even aware that an attack is happening, but your data is in the hands of those servers. So this is the primary challenge, that the user has no idea that an attack is happening and they are not there to witness it firsthand. So the network administrator has to have an eye on each bucket. Uh, Not each bucket, but at least every server, every data entry is stored over there. Now, how is this possible with the increasing volume of cloud networks? Right? A normal corporate organization can have their own corporate network and monitor the traffic going through their servers.
Yeah, yeah,
It is
okay.
possible at a local level, global level.
Thank you. Yeah.
Is important. Yeah.
Thank you, Tushar. Thank you.
Thank you.
So we have our next presenter with us, Shailesh, who would be
Yes.
presenting a paper on color image data fusion and view of image, thresholding and segmentation.
Yes, madam.
Yes, sir. Please share your screen.
Madam, yeah, everybody's there.
Yes, 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 sir. You can start.
Okay. Good afternoon, everyone. So my paper ID is 846 and color image data fusion in a view of image segment thresholding and segmentation. So this my name is Shailesh Pandare from Baba Saheb Nagpur University and co-author is Dr. Nilesh Thakur, sir. So yeah, so this is my abstract. Then introduction, then literature survey, and propose approach block diagrams and propose approach of data figure, and then final fusion data figure, and then we have a results and comparison. And last one is a conclusion. So whenever we have image segmentation, so image segmentation is the key and important process in the image analysis. In a general, thresholding technique is used for the gray level image segmentation, and then it can come to apply for the color images. The RGB color image is separated in three gray level plates, and then it can be applied on those gray level plates, or else color images is directly converted to gray level image, and then it can be applied into converted gray level images. So these our that is our papers address the issue of that is regarding the three color level plates here, and then we can be without using the inbuilt function which is available in the MATLAB. Again here, that is we have here the data fusion. So these data fusion approaches for the proposed system based on the achromatic coefficient. The single gray level image is formed for the available
that is RGB gray level planes by using the trigonometric function. Results are compared and with the bi-level multi-thresholding level and Auspuff's bi-level thresholding, and to obtain it shows that this converted image is having a difference, that is means it is the result is improved. Then we have here, that is as far as this introduction is concerned here. Image segmentation is a typical complex problem from image processing. Different techniques are reported. Multi-level thresholding data segments are used and color images. And then thresholding technique is used also gray level images when they are using in the color images are converted into gray level by using the existing functions available with the top. That is, we have RGB2 gray level. There is a function somewhere. So proposed approach uses the data of three gray level planes of RGB color space image, and then data is used by using the proposed approach of data filter, and further using the built-in function after as per this mechanism. So there is a problem formulation. So we have that is a problem formulations are there. This problem formulation that modify the trigonometric coefficient evaluation approach is proposed, and then a trigonometric coefficient based data fusion approach is proposed. And basically, so this is our that is a block diagram, and that block diagram shows here that is exact that is a process which is adopted in a particular data fusion system. So this we have image, and that image is a color image. So we have a two that is a process are there. So this one is a one process, and this one is another process. So here that is we have read that's what exactly we have proposed. We have proposed this particular system here in our that is in our research work. So we have color image. This color image is separated. That is R, G, and B, and there are the gray level plates. And then we have highlighted, we have a formula, and according to this formula, we have let the trigonometric coefficient of each RGB level plate, and then that will be a fuse. And after that, we convert that image into the gray level. And converted gray level image is given to the that is a standard that is OSTU method for the segmentation or thresholding, to bi-level thresholding, and then multi-level. And there once its output will be given, and then we compare the traditional methods here. So these are traditional methods are this one, there's also and multi-level thresholding, and then we compare these results as far as this our result is concerned. And it shows that our result is the best result as far as this plane is concerned here. And then we use it there, that is as far as this for calculating the that is the trigonometry coefficient values are, that is the individual that is the equations are to be given. And finally we have given here that is the coefficients for each and every level for RGB colors space images, and these are the equations which will help for calculating the that is RGB plane that is trigonometric coefficients. So these are the conventions here. So finally, that is what we are doing here. That is we are doing here. That is a final fusion. What exactly we require here? We read the image, then separate the three pillar. That is a gray level plane. That is RGB, and after that evaluate the topological functions for the there is a three planes, and then fuse the data obtained from the page. There is a step number 3, and then we are using that is as per this, there is the intensity level. Always we work on a intensity from the beginning. We are taken when you are when you are separating the that is the colors. So we focus on the intensity. According to this intensity, we have a formula, and according to this formula, we will get a particular results, and then it will compare with a particular number of that is evaluated the multiple process using the number of that is classes. And according to that one, we have experimented this with the help of this processor, the I3 processor. And then we have here that is images are there, original image. Then different there is planes are there, RGB planes are there, and their threshold, their histograms are available there. then the histograms are available there. And then according to these methods, as far as the standard methods are there, first to thresholding method, that is we have calculated the R plane, G plane, and there is a B plane. And as far as this thresholding image is concerned, so these are the according to and the thresholding. Thresholding is that is we have a scopes and there is a threshold multi-level thresholding system, and we have calculated this particulars. Again, we have compared their histograms as per this tachometric coefficient is concerned in terms of R, G, and B plane. Then we found that that is as far as this level image is concerned. So if you observe this particular table, then you will find that that is what exactly traditional methods are
Dear
cost methods.
presenter, you have 2 minutes left.
We have that is the traditional methods, and they have maximum intensity and minimum intensity. And we propose our approach is that as far as this PC is concerned, this means trichometric coefficient is concerned, they have got the better results as far as this one is concerned. And finally, so I have that is a particular minimum and maximum average trichometric coefficients for the RGB gray plane level. There's a minimum and maximum and average. And we found that that is these average systems will play that is the major role shares. So here is our conclusion. So this conclusion means we get a better result as far as this color space is concerned only, because we have many that is multi-level thresholdings and that is fusion techniques are there, but we work on only on a color space and they get that is a better results as far as this our method is concerned. And last one is feature is that is we should work on that is variance or there is a clusters as per this future work is concerned. Because whenever we are making the more clusters, so the speed that is what that is the time the computation time will be increased here. So it should be bonded that is the clusterings are that is suppose 5 group, and that's why we got there is a 4 that is the threshold value. Thank you, sir. Thank you, madam.
Thank you, sir.
These are the references.
Yes, sir. Any questions?
Yeah, Shailesh, there is a one question to you.
Yes.
Would you like to explore a specific fusion technique or a particular industries like medical imaging or remote sensing where these methods are applied?
So we are highlighting that the only images, not medical images. So these ones generalized images we are taken.
My suggestion is, if possible, you had to extend in the particular
Yes,
industry.
yes, sir, yes, sir.
Yeah. Thank you, sir. Thank you.
Okay, thank you, sir.
Thank you. We have our next presenter with us, Rajni, who would be presenting a paper on cybersecurity and its vulnerabilities, a review. Yes, ma'am. Can you share your screen, please?
Yes, ma'am. Good afternoon, all present. Today, my topic for presentation is cybersecurity and its vulnerabilities. And my co-authors are Parminder Kaur and Harminder Kaur. These are the contents of my paper: Introduction, Types of Cyber Attacks, Current Cybersecurity Threats, Vulnerabilities in Cybersecurity Systems, Threats, Vulnerability and their Mitigation Techniques, and Conclusion. Introduction. Today, Internet has removed all the hurdles and provide a way to communicate, play games, make friends, listen to music, and celebrate birthday and anniversary. In digitized world, the peril posed by the cyber threats cannot be overstated. Countries, organizations, and individual users all are concerned about the hazards to the confidentiality, integrity, and availability of the digitized information. The interconnectedness of the modern system amplifies the vulnerabilities of personal data, corporate secrets, and the national security information, underscoring the necessity for the robust cybersecurity measures. As the organization increasingly rely on the digital infrastructure, so they expose themselves to an array of cyber threats that can compromise the sensitive information and the disrupt operations. Hence, the integration of robust cybersecurity practice is critical as it directly influences an organization against the evolving threats in today's interconnected landscape. Uh, Types of attacks. The first one is the phishing attack. Phishing is a type of online fraud in which the scammers grab the sensitive information, including the credit card, login credentials, personal identification details, by sending an email and messages designed to appear legitimate. Phishing causes not only financial loss but also has indirect loss like customer trust, reputation damage, and the expenditure associated with the legal actions and the remediations. Like in this figure, hacker targeting the user, and the attacker send the phishing mail to the target, and the victim click on the phishing mail, and the hacker collect all the information about the target user. Next one is the DDoS, that is the distributor denial of service attack. In distributor denial of service attack, a cyber criminals overwhelm the server at the point that the system is unable to reply to the valid service request. The target sites get flooded with the illegitimate services request because the server has to respond to each request. So the resources get consumed by all the requests. This make it impossible for the server to serve the valid user request. Resulting in requests that are unserviceable, draining resources and the bandwidth, or completely shutting down the system. TCP, SYN flood, teardrops, UDP flood, and the botnets are the few types of DDoS attacks. Next, in the man in the middle attack. In man in middle attack, the breaches in the cyber security in which the attacker is secretly involved in the communication between the two parties. This attack allowed the scammers to steal the credentials and the personal information, read and modify the information transmitted between the victims. Next one is the SQL injection attack, structured query language injection. Structured query language injection takes the advantage of the website that depends on the database to serve the request of their user. SQL injection attack allow the attacker to insert the SQL commands via the input data from the client into the database. SQL injection exfoliates the information sensitive data from the database, modify the database, and perform the administrative level operation, such as shutting down the database software and recovering the content of a particular file present in the DBMS. Next one is the malware attacks. Malware is a malicious software that is designed to disrupt the normal operation of any system, steal information, and install itself into the user computers without any consent of the user. These are the types of malware, like the ransomware, spyware, adware, worms, trojans, and the botnets. Next attack is the cross-site scripting attack. In cross-site scripting attack is also known as a cross-code execution. In this attack is this attack enable the attackers to inject the malicious script into the trusted websites. This type of attack occur when an application includes untrusted data without proper validations, allowing the execution of arbitrary JavaScript in the context of a user browser session. Next one is the password attack. This is a common type of attack. In this attack, the scammer attempted to guess or crack the user password. This attack can be carried out against the individual as well as the organizations to seize their passwords of any field, such as the social media, financial apps, software, networks, and technologies that require password to access them. Brute force and the dictionary are the two methods used to grab the passwords. Next one is the drive-by download attack. In this attack, the attacker embeds the malicious code into the website. When the user visits such website, the malicious code download automatically and infect the user computer. Current cyber security threats. The landscape of the cyber security is increasingly threatened by the sophisticated adversary who continue to seek out the vulnerabilities within the digital infrastructure. Current challenges include the exploitations of Internet of Things devices, which often lack security measures, making them the prime target for the cyber criminals. The rise of ransomware attack further
Yes,
exacerbates.
presenter, you have 2 minutes left.
Okay, ma'am. With the malicious attack, leveraging the advanced techniques to encrypt the organizational data and demanding the hefty ransom for its release. Moreover, the emergence of threats such as the quantum computing pose potential risk to the traditional encryption method, necessitating the urgent attention and the adaptation. Next one is the vulnerabilities in the cybersecurity system. As the organization adopt the cloud computing and the edge computing technology, new security challenges emerge, including the data breaches and the unauthorized access driven by the decentralized nature of the system. Adaptive algorithms can enhance the resilience of the cloud and the edge environment against such attacks. Uh, these are the threats, vulnerabilities, and their mitigation techniques. Like the phishing in the phishing attack, the vulnerabilities are buffer overflow, zero-day browser vulnerabilities, voice over internet protocols, SMS, instant messages, and the mitigation technique is awareness among people. Email filtering, multi-factor authentication, regular patching and updating, anti-phishing toolbars. Distributed denial of service attack. Vulnerabilities are volume-based overload, service disruption, dependency on botnet, reflection and the amplification attack, protocol exploitation attack, lack of differentiation between the legitimate and the malicious traffic. And the mitigation is packet dropping, traffic redirected, and the traffic isolation. Man-in-middle attack. Vulnerabilities are communication protocol weakness, unsecure Wi-Fi network, lack of encryption, flaws in the protocols like the ARP and the DNS. And the mitigation techniques are implement the strong encryption protocols like the TSL and the SSL, use a secure network, employ the authentication mechanism, regular update the software. SQL injection attack. The vulnerabilities in this attack are a lack of input validation, improper error handling, dynamic SQL queries, insufficient authentication and the authorization, data misconfiguration, insecure database connection. And the mitigation is techniques are input validation and the sanitization. Use parameterized query, use ORM tools, web application firewalls, cross-site scripting. The mitigation techniques are input validation, output encoding, content security policy. For the password attack, mitigation techniques are strong, use a strong password policy, multi-factor authentication, account lockout mechanism. This is the conclusion of my paper. Uh, references for my paper. And thank you.
Thank you, Rajni. Thank you. Any questions, sir?
Yeah, Ms. Sarti, tell me one thing that how you can balance the balance between the usability and security in modern digital system, particularly in cloud environments and mobile devices.
Sir, sorry.
How you can handle
Repeat.
the how can you put the balance between usability and security in modern digital system? I'm talking about particularly in cloud environment as well as mobile devices. Are you getting my question?
Yes, sir. Actually, sir, I am currently working on only DDoS attack.
Okay.
So,
Okay. So, what are the most critical cybersecurity vulnerabilities in modern digital infrastructure?
Mainly the IoT devices that are connected.
And again, the question arises here that how you can emerging technologies mitigate this risk.
Emerging technologies.
Okay, no
Sorry,
issue.
sir.
Okay, no,
Sorry.
good work. Yeah, sure. Thank you.
Thank you.
Yeah.
Thank you, sir.
Thank you, Rajni. Thank you. Thank you, sir. Okay, so we move on to our next presentation. We have Shubham Garg, who would be presenting the paper on design and implementation of approximate adders for power constraint intelligent edge device. Yes, Shubham.
Good afternoon, everyone. I will just share my screen.
Yes, please.
Am I audible?
Yes, you're audible.
Okay. And is my screen visible?
Yeah.
Thank you. Good afternoon, everyone. I am Shubham Garg, and today I will be presenting our paper titled Design and Implementation of Approximate Adders for Power Constrained Intelligent Edge Devices. So this is the outline of our paper, that is introduction, background, proposed design, simulation results, conclusion, and references. The use of edge devices have been increased rapidly over the past few years. It can be seen in wide range of applications such as communication, healthcare, industrial automation, and surveillance. The edge devices perform computations locally in contrast to the conventional systems which perform computations on cloud or high-end servers. These high-end systems focus on achieving high accuracy on the cost of higher power and area consumption. However, achieving the same level of accuracy is difficult for the edge devices due to the energy constraints in the edge devices. To address this challenge, approximate computing has emerged as a potential solution since it provides, it reduces the energy consumption while maintaining acceptable levels of accuracy by relaxing the computational requirements. Now, in our paper, we have focused on targeting the adder at hardware level for approximating design to understand that it is important to start with conventional adder first. So conventional adder consists of three inputs, that is A, B, and C in, and produces the outputs, that is sum and C out. We can see the expressions are mentioned here for sum and C out, and the sum is calculating using the XOR of the three inputs, and the C out is calculating using the majority logic. However, while implementing this full adder using the standard CMOS logic, it requires 28 transistors, and XOR gates are the power hungry circuits. So thus, in this work, we propose to develop two novel configuration of approximate adders to achieve lower power consumption while maintaining susceptible levels of accuracy. So we can see this is our proposed approximate adder 1 configuration. So as shown in the schematic, we can see the schematic utilizes 3 AND gates and 1 3-input OR gate. We can see the K-map of the proposed approximate adder as well. Here what we have done is we have used the conventional majority logic to take the C out output. Just a second, I will use the pointer. Yeah. So we can see here is the C out output, which is calculated conventionally, which we can see from this equation as well. However, for the sum output, we have used the complement of C out output. As a result, the number of transistors used in this configuration are 2 less than the transistors used in CMOS implementation of the conventional full adder. Now, moving on towards the approximate adder second configuration. So in this, we have used the previous approximate adder configuration, and we have performed the logic optimization in the K-map of the previous adder. As can be seen in this image, the K-map is being optimized, thus reducing the optimizing the approximate adder logic. And we can see as a result, we only require 2 NAND gates and 1 2-input OR gate for its implementation. And the output equations, logical expression, are shown here. This is the expression for sum and for C out. As a result, it requires only 14 transistors for the implementation. Now, moving towards the truth table for the proposed designs, We can see on the left side, we have the conventional full adders, that is the inputs and the outputs, where A, B, C, N are the inputs for conventional full adder, and sum and Cout, these are the outputs. Okay. So in the proposed work, we can see for the first configuration and second configuration, sum and Cout outputs are shown. So in these, for the first configuration shows no inaccuracies in the Cout, but shows only 2 accuracies in the sum. However, in the second configuration of proposed approximate adder, there is only 1 inaccuracy in Cout and 3 inaccuracies in the sum. Now, here are the simulation results of the proposed work. We have compared our proposed approximate adder 1 and proposed approximate adder 2 configurations with the exact full adders for the metrics like power, delay, area, and power delay product. We can see from the results that the power, area, and delay are reduced with a substantial amount as compared to the conventional or exact full adders. Furthermore, to expand our analysis, we also proposed the conventional 8-bit carry adders like ripple carry adder, carry select adder, and carry save adder. And we used our proposed approximate adder for least significant bits to reduce the energy requirements while maintaining a susceptible level of accuracy. Again, to extend our analysis, we have also calculated few error metrics, that is the error distance for our proposed approximate adder, so that we can see that our energy, area, and delay requirements are reduced while maintaining the precision and accuracy. So here we can see this is the ED1 and ED2 specifies the error distance. That is the difference between the actual value and the approximated value. So we can see that here where we have encircled the EDs. So here sum is 0 for the conventional sum ACG. This sum is 0 minus this sum approximate. So these are the error distance values which are calculated. So this was our design here, where we proposed 2 novel approximate adder configurations. We have analyzed the proposed circuits in terms of power, delay, area, and PDB, and we have seen the substantial decrease in these parameters. For further analysis, we also calculated error metrics such as error distance. And finally, we extended our proposed designs with 8-bit adders to demonstrate the decrease in power delay product and area for approximate adders, thus making it suitable for different applications. So these are the references. Thank you.
Thank you, sir. Thank you, Shubham. Any questions, sir?
So my question that how can system designers make trade-off between performance metrics, for example, latency, throughput, accuracy, and energy consumption? So especially in resource-constrained environments.
Okay, sir. See, while creating an approximate application for edge device, we have our energy constraints. So we try to reduce those energy constraints with the trade-off with the accuracy. So as a designer, it is up to us how much we want to relax our constraint, because like in this constraint, we analyze the error matrix, because we need to be sure that reducing the energy constraints should not have very high impact on error matrix. So that's why as a designer, it is up to the application or the functionality of the design which we are proposing, that we need to see how much trade-off we can handle for that particular edge device.
Very good. Thank you.
Thank you so much.
Thank you, Shubham. Okay, so we move on with our next presentation. Mirza Zubair. Okay, sorry. Do we have Param Pratha Sanyal, who would be presenting a paper on enhanced myocardial infarction prediction using stacking ensemble approach?
Yes, ma'am, I'm ready with my presentation.
Yes, please,
So-
you can start.
Please let me know, am I audible?
Yes, you're audible.
Yes. Please let me know. Can the
Yeah,
screen be
yeah.
seen to you? Yes. So first of all, very good evening to the respected session chair present over here. Myself, Parambrata from Symbiosis Institute of Technology, Nagpur. Today I will be presenting with my research paper entitled Enhanced Myocardial Infarction Prediction using Stacking Ensemble Model. So coming to the contents. I'm very sorry for the inconvenience. Please let me share once again. Yes. So, coming to the contents of my today's presentation, I will be going through the abstract introduction, motivation, model flow, model architecture, and conclusion of this research. Coming to the abstract,
Is there any problem, Paramprata?
actually I'm sharing, I don't know.
Your screen is visible,
Yes.
but it goes away again.
Yes.
Yeah, now it's on the abstract.
Yes. Yes. So in our presentation, we'll be going through the basics of what is myocardial infarction, what our model is, and we'll be going through the literature review of the similar machine learning models and our evaluation metrics and highlighting the future research scope. So coming to the introduction, what myocardial infarction is, it is basically heart attack. It has become a significant global health concern across the globe. So in this transit scenario, the early detection and accurate timely prediction of this disease is absolutely significant. So in this case, the role of machine learning model plays a key role. So what we have done, we have taken a historical data set from IEEE repository, and we have employed our stacking ensemble model, which stacks two of the machine learning algorithms, support vector machines and CB, and also we have employed PSO for hyperparameter tuning of our model. So the motivation of our research has been the increasing cases of the myocardial infarction, also the leading causes of the death across the globe. So this is our model flow. As I have already mentioned, from IEEE data port, we have acquired the data set, and then we have performed some feature engineering, and we have compared the model with several other machine learning models, such as gradient boosting, naive Bayes, and support vector machines as well. The reason behind taking these three algorithms are actually most of the past literature review that we have reviewed, they have used this model. So we have taken this. And our machine learning model is a stacking ensemble one, which stacks light gradient boost and cat boost. And while the others have used grid search CV for their hyperparameter tuning, we have used the particle swarm optimization to fine tune the parameters. And this actually enhances the result of the models. And furthermore, this is the pictorial representation of our architecture of the model. First, we have acquired the data in the CSV form. After pre-processing, we have splitted the data into 20% of testing and 80% of the training data. We have, with the training data, we have trained the ML models, and employing that trained ML model into the test data, we have come up with the results. As this is a segmentation model, this regression model. We have taken evaluation metrics as accuracy, precision, recall, and F1 scores. And these are the results. As we can see, the proposed stacking ensemble model clearly shows superiority in all the four metrics that we have used. Uh, and we have compared with the most used machine learning models as well. So in future, uh, we would recommend the researchers to carry on with the deep learning techniques and integrate these into the historical data set so that the presentation can be optimized furthermore. So this brings up to the end of my presentation. Uh, I'm open for any sort of.
Thank you. Thank you, Param. Any questions, sir?
So, Mr. Sanyal, the question is that uh, how diverse-based models in stacking ensemble can capture different aspects of myocardial interaction, such as we can say heart function or abnormal tissue responses or other disease progression.
Well, actually, it is based on the historical data sets that we have used. And all the points you have mentioned has been the features of the historical data set. So,
Okay,
we
and
have
how can
trained the model with the data set.
how can
Yes, sir.
improve the accuracy and robustness of myocardial interaction prediction in the medical imaging or diagnostic system?
We can integrate the models with the patient diagnostic results as it has been done in the historical data set. They are providing the features of these.
Yeah, I am agree that
Again,
historical data
yes,
can
sir.
provide the each and
Yes.
everything, but in a practical, how can improve the accuracy and robustness of myocardial interaction prediction?
But sir, I'm not fully aware of that. But what I have observed that we can integrate as a patient data is there, we can integrate these models to their reports.
Yeah, because you are using SVM, whatever you are telling, told me
Yes.
different. Yeah. Okay. Thank you.
Thank you. Thank you.
Thank you. We have our next presenter with us, Mirza Zubair, who would be presenting a paper on optimizing quantum computer simulator performance of GPU accelerated approach. Yes, sir, you can share your screen.
Yeah, am I audible?
Yeah.
Okay. Okay, now I hope my screen is visible.
Yeah.
Okay, so good afternoon all. Myself Mirza Zubair Beg and I'm presenting paper on optimizing quantum computer simulator performance with the help of a GPUs. So basically, let's see what is actually a quantum simulator. Quantum simulator is basically and can be any hardware or software which mimic the behavior of a quantum system. It basically useful in the design and development of the quantum algorithms. But the main challenge in quantum simulations are these simulations are very resource hungry. As the qubit size increases, the number of resources in the system it grows exponentially. So even if we increase the resources, the time taken by the simulation also increases exponentially. So hence we can't simulate a more number of qubits in the classical machine, which having only CPUs. So to overcome with this problem, we have come up with a solution. So in the simulation, what parameters, what are the computation which is resource hungry, we will offload it to the GPU for the faster performance. As most of the quantum simulators uses matrices operations like matrix multiplication and all, these type of operation can be more fastly executed on a GPU rather than a CPU. So our objective of the main of the research to accelerate a indigenous density matrix-based quantum simulator, which is developed by IISc Bangalore and hosted on this QC toolkit.in, which was earlier only based on a CPU model, but now we have ported it to the GPU, and it's much more faster than before. Okay, the same thing explained here. So any application or any code which we are accelerating, the first thing is to do the profiling. Profiling helps us in identifying the bottlenecks in our code, where our code is actually lagging. If our code is actually executing on a CPU, how much resources it's consuming, and on a particular timeline, how our CPU is acting, if it is actually using or waiting for some data to come from IO or memory. So this type of this type of profiling, we have used the NVIDIA Insight system. It's a profiler built by the NVIDIA. The benefits of Insight system is we can visualize the total execution start to end on the what do you call timeline. In the particular timeline, suppose if I run a 30-second code, the whole timeline appears in the NVIDIA Insight system, which tells where the code, on which timeline the code has paused for a memory bound operations, IO operations, and when the CPU is actually doing some computations. So when we have actually used the NVIDIA Insight system for profiling, these are the profiling summary. This no, not the all profiling results, because it's very large, just a profiling summary. Here you can see this, these are the functions name. These are we are simulator based on Python. So these are the functions name in the right side, and the first column shows how much time it took to complete this function. So we have run a small code of 10 qubit system which took around 37 seconds, and these 37 seconds, the 68% of the code is taken by the compute density matrix function, 24% this, 3.1% of this. So the first four functions are time consuming, and rest are just negligible. So next we have to use the Insight system to see how these functions are actually acting. Is actually it is a memory bound operations are doing, or it's a CPU bound. So we have found out that these three functions, that add, deconus, and amp decay, add unitary 2 and add unitary single, are actually using a much more CPU. And the first function, compute density matrix function, is actually a memory bound most of the time. So we have decided to move the second, third, and fourth function to the GPU to get some acceleration. For this part, we have used a CuPy library, which helped us in porting the NumPy code into the GPU. So after the porting of this thing, these are the results that we got. In the 8 qubit circuit, the CPU and GPU perform almost in a 2 seconds. In the 9 qubit, almost 2 seconds. But as the qubits increases, suppose it's a 14 qubit circuit, we took CPU to around 1836 seconds, and in the GPU it's around 10,000 seconds, or 18,000 and 10,000 seconds. So there's a difference of 8,000 seconds in the CPU versus GPU performance. But that also not that much fast that we have assumed it. So we have profiled the code once again. So after the profilation, we got that these are the three things which we have moved to the GPU. We have saw that actual competition has got uh, uh, very fast. Like previously, this function is taking 24% of the time, but now it has reduced to just 1%. So more and more using an Insight system, we got to know that it's not actually the functions, but actually the data transfer between CPUs and GPUs taking much more time. Once again. Okay, so the data transfer between CPUs and GPUs were taking much more time. Hence, we have find out what are the functions where unnecessary data transfer is happening between CPUs and GPUs. And later we have reduced it, and we have
Dear
called this.
presenter, you have 2 minutes left.
Okay, so we have called this model as GPU V2. In the GPU V2, you can see that the performance have improved very much in the comparison to the CPU, which was taking 18,000 seconds previously, is now taking only a 2,000 second. So moving fast forward, these are the same thing which compares CPU with the GPU V1 and GPU V2, where it shows the significant improvement in a GPU V2 version. We have profiled the code once again to see what are other things can be done. So we have find out that hybrid approach can also be used, so that both CPUs and GPUs can work together to perform a more faster operations. Hence we have used this compute density metric function to parallelize on a CPU itself. And after parallelizing on a CPU, these CPU GPU hybrid approach took us just 241 second, and the actual competition, which was taking much more time, like the first one that took around 18,000 second, here it took 23,000 second on a CPU only CPU approach, and 241 second on a CPU GPU hybrid approach. So the conclusion to our research is the GPU can be used where the more and more matrices based NumPy based operations are there. We can use a GPU to took much more faster results. Hybrid CPU GPU approach can be also be used where some computation can't be transferred to the GPU, where we can use a CPU GPU hybrid approach for the better performance. Our future work includes multi-GPU and distributed computing. So more multiple GPUs can be used for a single simulation, porting the simulator to the NEC vector nodes, and moving forward. Okay, so these are our future work. So that's it from me. I'm open for any question.
Thank you. Any questions, sir?
Yeah, Mirza, my question is that would you like to delve deeper into specific quantum simulation algorithms or focus on particular types of quantum system? For example, qubit
No,
based
sir.
or quantum annealing?
This just a generic quantum simulator. It is density based quantum simulator, and this quantum simulator is actually developed by IIT Bangalore. So it can be used for multiple algorithms, design and development of multiple algorithms.
And then how you can, that means how the parallel processing capabilities of GPUs can be used to accelerate the simulation of quantum system?
Because this simulator actually heavily relies on the NumPy based operations. The larger NumPy circuits, like around 500 GB matrix is getting created in the simulator. So if we just a small scalar multiplication with the 500 GB matrix would take a long time on a CPU, but the same multiplication is when we run it on a GPU, it has much more faster response time, computation time. So we have identified that sections where the NumPy is much more involved, and that NumPy based matrix operations we have shifted to the GPU using a cube.
This is your PhD research work?
No, sir. I'm working for a CDAC.
Okay.
Yeah.
Okay. Good. Thank you. Thank you very much.
Thank you, sir.
Thank you, Mirza. Thank you.
Thank you.
So we have our next presenter with us, Kushi Kumari, who would be presenting a paper on stereoscopic scalable quantum convolutional neural networks with banyan tree growth optimization for predicting IoT security attacks by Mirai malware. Yes, Kushi, can you please share your screen?
Yes, ma'am. Is my screen visible, ma'am?
Yes.
So the title of my paper is stereoscopic scalable quantum convolutional neural networks with banyan tree growth optimization for predicting IoT security attacks by Mirai malware. The co-authors of my paper are Dr. S. Ravi Kumar, M. Gayatri, K. Deepika Nagashri, N. Gayatri, and S. K. Suma. So the problem statement of my paper is that these days the complexity of IoT malware attacks is increasing day by day, like Mirai malware and rest other attacks. And we are facing so many challenges in detecting these type of attacks due to the noise data scalability and computational limitations. So we propose a solution, a framework combining global local depth normalization for preprocessing, hybrid gooseneck bar-nickel optimization, and human memory optimization for feature selection, stereoscopic quantum CNN optimized with banyan tree growth optimization for classification. So we achieve we using this proposed solution, we can achieve a accuracy of 99.67% and a precision of 99.61% with minimal computational overhead. So these days, the IoT security challenges are increasing day by day, and we are facing lots of challenges in identifying these type of attacks, like Mirai botnets, which cause DDoS attacks. The traditional methods are available, but there are few limitations of the traditional methods, like poor scalability in large IoT networks, high dependency on label data, ineffective generalization for new attack types. So we propose a framework which integrates advanced preprocessing, feature selection, and quantum enhanced classification to improve scalability, accuracy, and efficiency. So, in this, we use innovative techniques like a global local depth normalization for noise reduction and feature normalization, hybrid gooseneck barnacle optimization, and human memory optimization for intelligent feature selection, and stereoscopic quantum convolutional neural networks with the banyan tree growth optimization for high accuracy classification. We use a network-based IoT data set featuring network traffic from IoT devices. The impact which is caused is that we get a system which is improve malware detection in IoTs, and there are reduced false negatives and false positives. These are the related works done by various authors in the previous years, and they have used LSVMs and CNNs and K-means algorithms and all this for their researches. So this is a proposed methodology in which we are taking a network-based IoT data set, which consists of more than 2 lakh plus datas, and which consists of different network traffic datasets, so that we can find and distinguish between Mirai attack and Mirai malware attacks. So next we are using global local depth normalization based preprocessing for ensuring the effective feature extraction. It combines both local depth normalization and global depth normalization to overcome challenges like slow learning rate. By normalizing locally and globally, it accelerates the learning process, and it also improves the difficulty in correcting minor depth errors. The method ensures better handling of small errors, particularly in dense complex regions with numerous primitives. In essence, it improves accuracy and efficiency of feature extraction, ensuring model performs well even in integrate regions of data. And then we use hybrid gooseneck barnacle optimization and human memory optimization based feature selection. This combines both GBO and HMO to optimize feature selection, predicting Mirai malware in IoT security. The integration of these both balances exploration and exploitation, improving prediction accuracy and reducing computational complexity. So what is a GBO? GBO means it's inspired by adaptability of gooseneck barnacles in marine environments. It focuses on direct exploration of multidimensional systems and helps in solving complex optimization problems. And what is HMO? HMO mimics the brain's memory processes. It uses prior knowledge for efficient decision making and improves adaptability. So by combining these both approaches, we get a hybrid approach which enhances the feature selection, boosting both accuracy and efficiency. And then for classification, we are using quantum convolutional neural uh, networks with banyan tree growth optimization. This approach combines uh, uh, both these for classification so that it enhances the prediction accuracy and improves IoT security threat detection. So by using all this, we get the output that if it is a non-Mirai, it is affected by Mirai or it is not affected by Mirai. And then we can calculate the performance using F1 squared precision, recall accuracy, and specificity. So we are using a quantum convolutional neural network structure. Actually, we are using this because it is different from the traditional convolutional network neural structure because it plays a very much important role in detecting Mirai malware attacks. Instead of processing images like traditional CNNs, it processes network traffic data to identify malicious patterns. So here we are taking an input which is IoT network
Mr.
traffic data.
Presenter, you
And
have 2 minutes left.
okay, ma'am. The IoT devices generate network traffic that can be either normal or infected with the data. And then this we take the input and we take a network based data set which contains features such as flow duration, protocol type, packet size, and many more. So then we use feature extraction. We do feature extraction using quantum CNN, in which we do, instead of using standard convolutional layers, we use quantum gates to extract features from network data. So after that, we can do the malware detection and classification to uh, uh, divide into two categories, which is Mirai affected and not non-Mirai affected. And then this is the framework which I explained right now is divided into four types, which is pre-processing, for which we are using GLDN, and for feature selection, as I explained before, that we are using both hybrid approaches, and for classification, we are using the quantum CNN, and for optimization, we'll use the banyan tree growth optimization, and at last we'll get the output. And this is the data set what we are using. And we are expecting a result, and I can explain the results through these graphs. As you can see that the training accuracy and the validation accuracy both are increasing based on the time. It shows that our model doesn't overfit and it is working very much fine. And the training loss and validation loss also decreases within time. So it shows that there is no overfitting in performance. And then here it shows that the true positive rate of this TPR goes on increasing, and it shows that model is working very much fine, and it is we are getting less false rates, and it is working very much fine. And then this is the training loss and validation loss, and it is decreasing by times, and it shows that our model is working fine. And we are using Python based for experimentation, and we get an accuracy of 99.67%, precision 99.61%, recall 99.63%, and F1 square 99.60%. This observation shows that it outperforms existing methods, and it is a very good proposed method. This shows the comparative analysis with existing methods. Before we used LSBMs and CNNs, which showed accuracy of 89% and 90%, but our proposed method shows the accuracy of almost 99.67%. And we achieved a high accuracy and low computational overhead. And it is also scalable for large IoT networks. And the limitations are that this is dependent on dataset diversity and challenges in real-time deployment. Future work we can do is that we can use it the hybrid approaches with deep learning, and we can extend to various IoT applications beyond Mirai malware. Thank you.
Thank you,
ma'am.
Sir. Any questions?
Yeah, there's one question that how you can identify challenges in implementing this system in a real-world IoT ecosystem, including quantum hardware limitations.
Can you repeat the question again, sir?
How you can identify challenges in implementing this system in a real-world IoT ecosystem?
It will be actually very tough to identify the real world challenges. So, as I said that, the challenges which we actually will be facing is in the real world when we try to implement this.
Okay,
Thing,
thank you.
we can face like scalability issues and security issues, sir, and we can even face like quantum hardware limitations. So, and we can address this using we can try to improve our design methodology and everything so that we can try to improve all this, sir.
Okay, thank you.
Thank you.
Thank you, Kushi. Thank you.
Thank you, ma'am.
So we have come to the end of the session. I sincerely thank our authors for their excellent presentation and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. And I, on behalf of the whole team, thank you for the support during this 9th version of this conference and for the previous 8th versions as well. I hope to see you in the 10th version, which is in 2026. All the presenters would be getting their digital certificates through email within 2 working days, and the papers have been forwarded to the Springer board, and the publication will be live within 6 months. So kindly cooperate with the team. I also thank our session chair for chairing the session. Thank you so much, sir, for chairing the session. This is
Thank
a
you.
token of appreciation from our side, sir. Thank you so much. It was great to have you on this platform.
Yeah.
Thank you, sir.
Thank you, Deepika. Yeah.
I also request all the participants to turn on their cameras for a quick snapshot of this virtual conference, please. Thank you, everyone. Thank you so much.
Yeah.
Thank you. Stay safe. Take care. Bye.
Yeah. Bye-bye.